Tangent line. So when you have a graph of a function and you are given a point A on the graph, the tangent line at this point is a line that touches the curve at only this one specific point, and the tangent line represents the slope of the curve at this point. And here's an example of how to find the tangent line at a certain point using derivative. So when you have the function of f of x equals x third plus 2x at point 1, 3, there are basically 3 steps that you can take in order to find the tangent line. The first step is to take the derivative of the original function. So you got f prime x equals 3x squared plus 2. And the second step is that you plug in the point into the derivative function in order to get a slope. So you plug in 1 into the f prime function and you got 5, which is the slope of the tangent line. And the third step is you lay out the point slope form equation, which is y minus y1 equals m times x minus x1. And you plug in the slope and the given point in order to get the function. And you finally simplify it and you got y equals 5x minus 2, which is the tangent line of the function f of x equals x to the third plus 2x at point 1, 3. L'Hopital's rule. When we're finding the limits of a function f of x as x approaches to a, we're simply plugging a into the function f of x in order to get the answer. But when we encounter problems when we plug in a into the function and get the answer of 0 over 0 or infinity over infinity, then we should use L'Hopital's rule to solve for the limits for these two specific conditions, which are the indeterminate form of limits. The way to evaluate an indeterminate form of limits, like f of x over g of x, is to get the derivative of the denominator and then the numerator separately. Note it is different from the quotient rule. Here is an example of using L'Hopital's rule to solve for a limit of a function. So when you're given a function ln x over x squared minus 1, and you are asked to solve for the limit of this function as x approaches to 1. You plug in 1 into this function and you get 0 over 0. So this function is an indeterminate form of limits. So we use L'Hopital's rules and we take the derivative of both the denominator and the numerator, and we got 1 over x over 2x. And then we plug in 1, and finally we got 1 over 2, which is the final answer of the limits of ln x over x squared minus 1 as x approaches to 1. Here's another example of using L'Hopital's rule to solve for the limits. You are given the function of x squared times e to the negative x, and we simplify it to get x squared over e to the x as x approaches to infinity. We plug in infinity into the function and we got infinity over infinity. So this time we use L'Hopital's rule to solve for this indeterminate form of limits. We take the derivative of both the denominator and the numerator, and we got 2x over e to the x as x approaches to infinity. And we plug in infinity, and again we got infinity over infinity. So we need to do L'Hopital's rules once again, and we take the derivative of 2x over e to the x, both the denominator and the numerator separately, and we got 2 over e to the x as x approaches to infinity. And this time we plug in infinity into the function and we got 0, which is the final limit for this equation.